All right, we're live almost. Yep, we're live.
Cool.
Okay. Right off the bat, we have to download two files. Did you guys do anything fun today? Did you have a day off at all, or?
No, regular day.
Everything is closed here in Rexburg.
Really?
Yeah. Like, there are even restaurants that are closed. I'm like, wow, cool. Well, this is a small town.
Right. All right, let me pull open the group quiz here.
Yeah, I wish we had a day off today. I was looking forward to a long extended weekend, but didn't happen. Oh.
Okay, you guys ready?
Yes, sir.
All right, let's do this. So use the following information for the next two questions. Suppose we have a data set. Let the difference x after equal x before. Okay. The null hypothesis is mu difference equals 0. The alternative hypothesis is mu difference is not equal to 0. And the population standard deviation sigma is not known. Jordan collects a sample size of N9 with a difference of 2.2 and I forget what the S stands for, of 3.3.
Standard. It's the standard deviation of the difference.
Gotcha. What is the value of the test statistic?
It would be 2.2, correct?
Yes, right? My confidence is shaking. Anybody?
You said it was what?
2.2.
That's what I got. That's what I'm thinking.
Okay.
Okay.
Question 4. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. Round to the third decimal place.
I don't remember reading about this.
Wouldn't it just be the same? Because if the probability of obtaining the test higher than this would be 0.40. No, because then we'd have to solve for that actual value, right?
Yeah.
So P equals, what was that equation that they gave us? D minus 0 over
Standard deviation, right?
standard deviation over the square root of n. That's our t value, right? Or is that the p value?
Wait. It's just over the standard deviation because S over square root of n is standard deviation. So, okay, I forget that we're using this information above. So, standard deviation is 3.3, and we're doing 0.403. So, is that 2.2 subtracted by 0.0403?
Hold on a sec. P value. Trying to find just a simple like formula for the p value because I don't remember. So I'm thinking if the probability, because if you read the question, it says that the probability that the statistic is greater than his test statistic, then they gave us a value. And then what is his p-value and his hypothesis test? I'm super confused. Like, why do they ask us the p-value if they already just They just gave us a p-value, if that makes sense. You know what I mean?
Yeah.
Um,
I'm trying to go back to the reading real quick, and I don't see anything that talks about it.
Yeah, I'm not seeing anything either. In step 3, we're given the same information. I don't know if that helps. We're given, yeah, not the same information, but the same set of information.
Well, would it be the same number, the same value as the 0.0403? Because I have no idea what they're trying to. What?
Yes. Oh, wait, here's one for p-value. No, that's not helping. Oh, okay, yeah. So we use your formula, and that gives us the t-value. Then we put it into the applet, and that gives us our p-value.
So what's the formula, though?
So it would be, what were those numbers again? 2.2 subtracted by 0 divided by 3.3 divided by the square root of 9.
But that's the t-value, right? That's not a p-value.
Yeah. And then we put that into the student t probability applet. So let's see. So it's giving me 2 when I put it into here.
Yeah, that would come out to 2. And then when you put it into your p-value, hold on, I got that one. For a z-value of 2, it would be 0.4 or 0.0455.
I'm not getting that. Hold on.
Are you using the z value or the t value?
Yeah, you should be using the t probability, not z.
Where'd that go?
So, because I'm looking at this right, I'm getting like 0.8607. Oh, wait, hold on.
But it has to be 0.8607. Is that what you said?
Yeah. But hold on.
What is the probability for his
Oh, yeah.
hypothesis test? That would make sense.
So it'd be 0.069.
Yeah, because if he's doing a one-sided test for something that's greater, and then you're trying to find something that's either or, it'd almost just be the double of the value they gave us, because it'd be both tails of the thing. Okay, so 0.8607, so 0.861.
Yeah. I don't know. That's what I see. Anybody else want to?
So what? Okay, sorry guys, I'm super lost on this one. What formula did you use to get that?
So in the reading, if you get to step 3, the first step 3, not the second step 3, it gives us. Go ahead. What?
I was going to say the one that the one that says step 3, give the relevant summary statistics from the Excel output illustrated above, or no?
Yeah, that one. So it gives a histogram at the bottom.
Right.
So if you start there and you go down 4, at the bottom of 4, it gives the formula for the t-value.
Oh, okay.
And then underneath that, it shows they use the answer from the t-value to put into that applet.
Gotcha.
The T-applet.
Yeah. Or is that the t-applet? There, hold on.
But they're asking us specifically to use the statistic, or sorry, the probability that it's greater, to use that number, but we didn't use that number in any of our calculations.
That's true. Would we subtract that from 2.2 then?
That would make sense, because then you take out the right side of wherever his statistic is, and that would give you a more accurate range. But I still don't really know how that, because I didn't read anything like that in the prep, so I don't even know.
Yeah, me neither. If that's the case, my answer that I'm getting from that one is now 1.963. And when I put that into the applet, 963, getting 0.8556, so basically 0.856.
Yeah, I don't even know. I'm so lost on this one right now. The probability of obtaining a test statistic. Yeah, I don't know. I'm gonna just keep going. Gonna have to read some more on that one because I have no clue.
So just a quick question for you guys. On that test statistic that they did, why did they subtract 0?
The only thing I can think of is because we don't have something to contrast it with.
Oh, okay.
We just don't have any information that conflicts with the difference. I don't know why the word difference is so hard for me to remember, but right. Man, I am.
So basically, it's because we don't know the standard or the sample size mean. Is that what it is?
That's all I can think of, is that we just don't have anything to remove from it. What if we move on and come back to that one?
I'm just trying to set up my formula real quick because I did not catch that earlier.
Okay, this is just probably a stupid question, but what's the difference between a p-value and the probability?
I honestly don't know.
Because isn't it the exact same?
That's what I thought.
Yeah, I've been treating them as if they're the same.
That p-value stands for calculated probability.
So is it all probability equal to 1? So we just take away his,
1
but
minus
that
0.0403.
Oh,
because then it would, I mean, but that's, I mean, it's very general, but it's asking for what was his p-value, his probability in his hypothesis test. It would have to be whatever's left, right? Because if you have something greater than his statistic on the right side, then whatever's left from the 1 would be where his boundaries were set. Or am I just nuts?
no, you're right, because all probability added should equal 1.
But that just seems so far like
That's a stretch.
behind for, yeah.
Yeah, because we don't cover anything like that in this chapter that I read, at least. I mean,
I didn't see anything in the videos either because I watched all the videos and I didn't see anything.
Right.
Yeah.
I honestly don't know.
well, let's come back to this one then.
Okay.
I mean, we still
Okay.
have
Yeah.
19 questions total.
Yeah.
We might find something that clears it up later, but if not, we can guess on that one. If that's the only one we get wrong, we can work on
Post a
figure
question on the
something else out.
discussion board and see if they answer.
Yeah, that's a good idea.
So question 5, right?
Yeah.
What is the value of the test statistic? Oh, you got to open up the
You have
data.
to, yeah. So I have 31.025.
I'm opening up the data real quick and then I'm assuming we just copy and paste it into that chart, right?
Yes.
Yeah.
All right.
Into the paired.
Right. Into variable 1 and 2.
Yeah. Mm-hmm.
And then it.
Okay.
What is the test statistic? So 31.025.
Yep, that's what I got.
Yeah, that's what I have. It's the same as the mean, right?
Yeah.
Yeah. Okay.
And then the p-value I'm getting 0.688774357. So
Yes. 0.689. Yep.
Yep.
And then what is the correct decision based on this evidence? Since p is greater than 0.01 or 0.1, we fail to reject the null hypothesis.
Yeah. Suppose your alternative hypothesis is instead greater than 0. What is the correct decision based on this evidence?
So if you change it to greater than,
right.
I still get a value bigger than 0.1.
Yeah, we have insufficient evidence. Is it we have insufficient evidence
That the mean of differences is greater than 0. Because we have to fail to reject it.
Yeah.
Still.
So
You
B?
put B.
Yeah, B.
Okay. Yeah, that's what I'm doing. Okay. Use sample data B1. Okay, let me move this stuff over then.
And then the level of significance for this is 0.01. So first question is, which is greater, n or df? And it's going to be n because df is just equal to n minus 1.
Oh, that's right.
Next question, what is the p-value rounded to the third decimal?
Wait, hold on.
Point
Say that
zero.
one more time. So yeah,
What
df
is
is
the-
n minus 1. Right.
Yeah.
Sorry,
yeah.
I interpret it backwards. Like that's not right. So yeah, keep going. Sorry.
And then question 10, what is the p-value? I got 0.001 rounded.
So wait, this is. Are we doing not equal to? We're doing equal to 0.
We're doing not equal to 0 for
Not
the
equal to 0
alternative.
for the
Okay, so yeah, now I'm getting 0.0012.
Yep.
Yeah.
0.
So 001.
Okay. And then what decision did you make?
You reject it, right?
Right, because it's bigger.
Greater than.
Well, yeah, because the significance level is higher than the p-value, so you reject the null hypothesis.
Okay. You decide to try another alternative hypothesis. This time it's less than 0.
No, greater than.
Greater than.
Greater than 0. Sorry. Yep. Yeah, I'm not.
Mm-hmm.
Yep. Greater than 0.
P-value decrease.
Yeah, it decreases.
Mm-hmm.
Okay.
Same decision, though, right?
What decision do you make? Yes, you still reject it. Hey, buddy.
Okay. What is the conclusion you make? We have sufficient.
I put C on this one.
Yeah,
so
let's
we
go
have
with
sufficient that there is a mean difference between the two groups.
Same. Well, especially if you rejected the null.
Right. Which was that it was equal to 0.
Right.
So, and then 15, as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
That's going to be right.
It's going to be greater than, right? Is that what you said, Matthew?
Yeah, so D. D is what I was saying,
Yeah.
very bottom.
Yeah. Okay, determine the 95% confidence interval for the mean difference between the two groups, group 1 and group 2. Input your answers below. What is the point estimate for this 95% confidence interval?
Hold on.
So our point estimate would just be the mean, right, of the differences?
That's right, so 11.955.
5.5, yeah, okay. And then the margin of error, 30.199.
What'd you get?
3.199.
Oh, okay.
Is that what
Sounded
you got?
like you said 30.199. I was like, that's a little off. That's a little off what I got.
It's a big margin of error here.
It's like 4 times the standard, the mean.
Yeah.
The lower bound, I'm getting 5.303.
Yep. But then upper bound 18.607.
Oh god. So nothing that we read helped us with number 4.
Nope.
Yeah, that one just seems way out of the blue here. I'm gonna go back and read it. Because it just says probability way too many times that I get lost.
I wonder if this is asking us if we understand that the probability is equal to the p-value.
Right, like I could see it going either way.
Yeah.
But what I'm understanding from the question is that the value they gave us is any values that you could get higher than what his test statistic would be his mean value. So anything higher than that has a probability of 0.04. And then it's asking us to figure out his p-value for when he did a hypothesis test, which is basically his, you have your 95 or 99 or 90% confidence interval. His p-value would be depending on what he used on that. You know what I mean?
Yeah.
So
I wish so badly this was multiple choice, so we'd have something to
Right.
choose.
Right. You have something to kind of plug and play.
Yeah,
okay,
dude.
so okay, guys, you ready for this? This is my last picking at straws here. So if you plug 0.0403 as your p-value and you click on the right tail of the normal probability applet, and then you just highlight the middle section, because that would be technically his range, I get 0.919 for his p-value of his hypothesis test or hypothesis interval.
So what did you do? So you went to the applet, the T probability applet.
The p, I used the p because we're using p-values, not t-values. So what I did is I just highlighted the right hand side, because his test score, or the probability of getting something higher than his statistic was 0.0403. So I highlighted the right tail and typed that in, right? So that gives us a graph with a z-value and everything else. Then I just highlighted just the middle section, because that would have been roughly his hypothesis test, right? Because it has an interval of where he was guessing the means were at. Does that make sense? Yes, no?
Yes.
I mean, kind of not.
Like, I understand what you're doing. Sorry, I'm trying to look back and see if we have a formula that we've used on how to calculate the p-value based off of
the possibility of getting it higher than his hypothesis, like his statistic. There's just too many like weird variables there, because it's not all just p-values. You know what I mean? The probability of obtaining a test statistic.
I'm gonna be honest, I still have no idea.
Yeah, there's only one reference to probability in this chapter, and it's referring to that app at the bottom where we did the formula, where you did the T formula and put it into the probability applet. And that's the only reference to probability.
Right. I don't even know if we've ever once gone from like a testing p-value to the original p-value using just your test statistics. Like, what? No clue how they expect us to figure that one out.
I don't even have an idea.
I'm tempted to,
what was that?
No, sorry. Go for it.
I was gonna say I'm tempted to just use the 0.0403
as the answer.
Yeah, just because we haven't covered it, so it would make me think that maybe they're trying to figure out if we understand that the probability is the same thing as the p-value when we have a test statistic. But like Garrett said, they keep throwing that it's greater than his test statistic. So now what's the probability for his hypothesis test? But my issue with that is like we haven't learned it yet. So I don't see like everything else, every other quiz we've ever had, like we've covered it. It's been in the chapter. We've been able to go back and see, exactly like read the formula or read this, read that, and be able to have an answer right in front of us. But I don't see anything that answers this question anywhere.
Yeah.
Hold on, I tried to Google it to see if maybe I could find a formula or something to see if we were missing something, but I don't see anything.
Baby. Tu hijo, por favor, casi termino. Oh, wow, gracias.
Is your wife Hispanic?
She's from Colombia.
Well, that's not his. Well, yeah, that's not Hispanic. That's Latin.
Yeah.
That's cool. Awesome.
Latino.
Yeah, I don't know. Maybe should we just try the 0403? I mean,
That's like the first thing that came to my mind when I was reading this, but I don't know. It still doesn't make too much sense. So whatever, we'll shoot for it. See what happens. At least that's where I'm at right now. All right, I'm submitting it.
unless is it simply just 1 subtracted by 0403? Because that would all be greater than, I don't know.
Well, the problem is they're asking between like the actual results and his hypothesis test, but we have no idea what kind of information he plugged in to get a test result. You know what I mean?
Yeah. Oh man.
So
okay.
It kind of just goes back and forth.
We can post on the forums and then see what other people say, and if that's the only thing we get wrong, even with that, I mean, we would still have A, right?
So I missed a couple of them, it looks like.
Oh, really? I've been submitting
Yeah.
mine, and then I'll join in.
Oh, sorry.
I haven't seen
Sorry.
mine either.
Oh yeah, we missed margin of error. Wait, we got 15 wrong?
Yeah.
How is that? It must be that we just don't have enough information. It depends on the problem then.
I got 5 wrong as well.
Yeah, me too. And that 0403 is wrong.
Yeah. Well, we got question 3 wrong as well.
What is the value of the test statistic? Well, okay.
Let's see. Oh, okay. So this would have been the 2.2 subtracted by 0.
Which one are you doing, Matt?
Sorry, 3. The test statistic.
Mm-hmm.
That's the formula D subtracted by what is it?
0
or whatever. Yeah, 0 divided by 3.3 divided by square root of 9.
But we just plugged those in. They just gave us the D value. It should be the same, right?
What does the line over the D mean?
It's the same. It's the same as like the sample mean of, the statistic mean where it's the X with the line. D line over it.
The line. Yeah. To reference it.
I have no idea. I like D with the line. That makes sense. I know what you're talking about. But because here in the reading it says that the true population mean will be labeled with mu D, and the sample mean will be labeled D with the line over it. So our test statistic should be the sample mean, right?
Yes. That's the way I understood it.
So did we compute something wrong, or did we just read something wrong? Well, we didn't have to compute anything, right? They just gave us the values. I'm so lost then on number 3.
Yeah, it's if it is that formula, then the answer is 2, not 2.2.
Yeah, it's 2 because that. Are you talking about, Matt, the test statistic formula where it says t equals and then negative 6.8 minus 0 divided by 3.17
Yeah.
divided by, yeah, so I got 2 as well. That's the one we were talking about originally using for number 4.
Yeah, but that
So
doesn't
it's
make sense.
2.
So now I'm really lost on 4.
Well, what if the value of the test statistic is 2 and the probability of obtaining a test statistic greater than his is 0.0403? Hold on. Let me pull this up before I start talking. So the t equals 2. How do you determine the degrees of freedom again? What is it? N minus 1, right?
Yeah.
Yeah.
Okay, so I think I got it. So if you go to that t probability and you change it to 8 degrees of freedom and then type in t equals 2.0.
Wait,
and
why
trade
8? Why 8 degrees of freedom?
Because we have n equals 9, so 9 minus 1 would be 8.
Oh, okay.
And then type in 2.0 for your t value. You get 0.0403 as greater than a t of 2.0. So then you shade everything under that and you get 0.9597, which is the same thing as 1 minus 0.0403. Does that make sense?
Yeah.
Yeah.
Which it makes sense, but it's still like nothing that we've ever talked about. So I don't know, why they would throw something like that at us. So 0.95 or 0.9597,
597.
but it's only to the third, so it'd be 0.96.
Yeah, so 0.9. Yeah, 0.96. I mean, it makes sense in the fact that, like, we know all probabilities are 1. So if the probability of obtaining a number greater than that, I don't know.
Yeah, it's just, yeah.
Because his test value is 2. So if the value of redoing this again and getting a value greater than 2 is 0.0403, the
Then
p value would be everything below it.
Gotcha.
Question 5 we also got wrong. Question 5 we just took that right out of the Excel spreadsheet though.
Yeah.
Right.
I don't know. Unless again we have to actually go through and calculate the test statistic, and that 31.025 is actually just the mean. So we have to do the 31.025 minus 0 divided by.
But we don't have any. Oh, we do have all the other stuff.
Yeah.
And then divided that by the the statistical difference, and then the square root of.
Yep. Of in this case it would be this whatever the value
values
is.
were in that.
Yeah, I'm trying to pull it all back up because I exited out of it.
This is for A1, right?
Yes. So our D is going to be that 31.025. We're not going to subtract anything from it because we don't have anything to compare it to. The S, what is it, the standard or something differences is going to be sorry, I'm still trying to pull it up.
So I just plugged in all my numbers again. Maybe I did that wrong. Where's my? Because I have a different mean value.
What do you have? Well, so make sure that you subtract.
Yeah.
Take
Well,
out sections
I had
27
two numbers in from the last one. So yeah. So I got the mean of the difference is 31.025. That's what we had the last time. Okay, so then you guys are taking that and subtracting 0 over. Is that what you're doing?
Yeah. So n is going to be 20.
31.
What is the SD?
SD is the standard deviation of the differences. So it'd be 76.285.
Where's that at?
It's in the difference
Okay, there it is.
column.
Wait.
Sorry,
That's
no, it's 341. Yeah.
So the answer that I get is 0.406.
Over square root of 20.
Actually, yeah, it's 0.407 is what I'm getting.
Sorry, I don't have fancy spreadsheets to do all these math calculations for me. 721 341.15.
I'm getting 0.407.
Yep, same.
Okay.
Yep, 0.407. Okay.
The next one we missed was 15.
Yeah. Wait. We also. Oh, yeah. Yes. Yeah. 15. I'm thinking it's that we don't have enough information.
Right, because it can depend on the percentage, right? Like how confident they are. Because if you take whatever we were doing last, which is what I did, and I just changed it from not equal to greater or smaller, the greater had the smallest p-value, but that's not always the case, I guess.
Yeah.
So it has to. The p-value depends on the alternative.
I think it depends on what the test statistic is, doesn't it?
Yeah, so the p-value formula uses square roots. It's divided by a square root, so that number could really drastically change based off of what number is being put in.
How many?
So we'll just put not enough information. Depends on.
Yeah, that's what I would say. It's just not enough info.
And then question 17, which we also just took off the thing.
But that was with the last values.
I'll put those back in.
What is the margin of error for 95% confidential?
Okay.
So it's weird that we got 16 right, but 17 wrong.
And then we also got 18 and 19 right.
Yeah. What is the margin of error? I'm still getting 3.199. So there has to be,
unless it's a rounding issue that we're supposed to give less. I don't know.
What are
you getting?
3.199. Because it should just be the difference of the two means, right? Which I got for variable 1, I have 3.417, and for variable 2, 1.517.
Could it just be the high end of the confidence interval subtracted by the low end of the confidence interval. In that case, it'd be 3.737.
Wait, what?
So it's asking for the margin of error for the confidence interval. Could it be the high end of the confidence interval subtracted by the low end, which, why am I getting 3.7? That's not right. Hold on.
Well, what kind of test is this? I don't see anything about the kind of test that it is. Do you? Is it because it's not question 12 still?
Right.
It?
It's just based off of the input of the question. So 15.
I'm still getting the exact same answers. Unless we're supposed to round up to 3.2.
Which is possible.
Because every other one says round to 3, round to 3, round to 3.
Hold on.
Mean of error.
Yeah, and even the answer says round to 3 decimal places unless otherwise specified, and it's not otherwise specified. So 3.199 would still make sense.
So I don't know why, but shouldn't the standard of error difference just be the margin of error of variable 1 and 2 added together and then divided by 2?
Say that again?
Right? The differences of the margin of error, shouldn't it just be the two different margins of error from variable 1 and 2 added together and then divided by 2? Because my Excel spreadsheet has H18 divided by the square root of F18, which has nothing to do with what I would imagine this. Does that make sense? Like, it's got a weird formula, but I don't know if that's how you find it.
Yeah, I'm not really sure because I'm not coming up with anything different. Well, like if I do what you were talking about, I got 2.466.
I mean, I don't imagine him getting that wrong with the formulas because all three of the boxes have the same formula in it.
Right.
I'm just really confused as to why the margin of error is based on the square root of 22. Standard deviation or square root of 22. Oh, that makes sense. Okay. So, but that would have to be times t. What's the formula for margin of error?
Looking
It's
that
like
up.
z or t times what, sigma over square root of n or something like that.
Okay, it's in less than 10 is margin of error. I'm not seeing a formula.
Go down to the summary of the section. Or like in the middle of it, it had m equals.
Yeah, z times sigma over square root of n.
So according to the Excel sheet that we used, all they did was had the standard deviation over the square root of n. So they had sigma over n, but they didn't multiply it by a z value or by a t value, if that makes sense. So I don't know if the formula in the sheet is wrong or if that's how it's supposed to be. But if m is equal to z times that, or sometimes we used t as well when we were doing the t values. So I don't know if we're supposed to multiply the t value of the differences times sigma over the square root of n. Because if that's the case, 3.737 times 3.1. Because if that's the case, I get 11.955 as the margin of error.
Yeah, but that's our mean.
Which is so weird. Why that worked out that way. I don't know, you guys. That's confusing. What is
Well,
the margin of error?
The margin of error formula is z times the mean divided by the square root of the sample size, right?
Mm-hmm.
Yeah.
So if we put that in, I got 4.995677.
But where did you get your z value? Or did you just plug in t?
No, z is, remember when you use confidence level of 95%, the z value is 1.96.
1.96.
Oh, you're right.
So I used 1.96 times 11.955 divided by the square root of 22, and I got 4.995677.
Wait, why did you put the mean in instead of the standard deviation?
No, you're right. It's the standard deviation. Let me change that real quick. So 15.003
divided by square root of 22.
So I got 6.269, which actually makes sense because if you take that and you multiply it by 2, that's the difference between the two confidence intervals.
Okay.
So you got, what did you say? 5?
Oh no, sorry. So
or 6
6.269. It doesn't equal the difference between the confidence intervals. I just did the math, but
yeah, that makes sense because that value that you gave us for the z makes way more sense than plugging in t or whatever. I don't even know why they have. What is the standard error of the mean supposed to mean if it's not the margin of error? Or is that just another statistical thing for
something there to throw us off? I have no idea.
Standard error of the mean. Yeah, I don't know, because that reads to me like standard deviation, meaning how far off is the mean from the rest of the means, but whatever. Okay.
Well, I'm looking at the the reading, and there's no mention of standard error of the mean.
Yeah, I couldn't find it either. I keep looking over
So
at
I wonder if maybe that's something that's coming.
Right.
Remember
as well
week,
as
we did,
as well as p-values for hypothesis tests.
Right.
Yeah.
So I think I'm gonna try that 6 point whatever it was.
Okay. Did we figure out let's see, 5, I got 5, 4. Did we decide what we were doing for 4? Anybody else have a
So
Oh yeah,
4,
it
I
was the 0.919, right?
0.91. I got 0.96, but that's because you have
Yeah,
to round to the 3 decimal places.
Yeah.
0.9597.
And
Yeah.
3 was just 2, right?
Yeah.
I
think those are the only ones we missed.
Yeah, I think so. And then the other one, we were just gonna say we needed more information to kind of determine that.
Yep.
Yeah.
All right.
All right. I'm going to submit
Sounds
it, see what
good.
happens.
Yeah. Good luck, guys.
I'm punching him back in.
All
We
right.
still missed a couple. We still missed that margin of error for 95%.
Really?
And we still missed the question 4 probability of a statistic, yada, yada, yada. So I got to get ready for work. But when I get to work tonight, when I get a chance to get to a computer, I'm going to post that on a discussion board and see if either
To
the
see if
instructor
anybody else.
or, the TA can answer. And if not, I think I'm off this Thursday, so I might just go to that class,
That session.
meeting and ask them. Yeah, and just be like, hey, we have no idea.
Yeah.
Well,
Yeah.
it would be nice if it showed you the answers, like after you're done with your 2 attempts.
Mm-hmm.
Yes, you can at least know what you did wrong.
Right. But it doesn't. Just tells you got them wrong. I'm going to stop the recording real quick.